Hi, so here are 5 mixed GCSE questions for you to try. They are mainly level 5 and 6, apart from these last 2 here, which are more like level 7 and level 8. These 3 with a non-calculator sign I'd like you to do without your calculator. Have a go at all 5. Once you've done them, then move on with the video and you will see the answers. If you get them all right, then you can stop there. If not, then you can move through the video and I'll go through each one of these questions one by one. Okay, so pause the video here and have a go at the questions. Right, so I'm going to show the answers. If you haven't done them yet, then you've got a final chance to pause, but here are the answers. So if you got all of these right, then well done. You can stop. If you got any one of them wrong, then look through the rest of the video at just that question. You can just scroll through and find the question you are looking for. Right, so I'm going to start with question 1. So this question here is not as easy as it might at first look, because we've got to find this angle here, which we call theta. That's a circle with a line through it, theta. We've got to find the angle. But for any triangle, and if we look at this top triangle, let's see if I can just draw around it so we can see what we're looking at. So the problem with this triangle here, this orange triangle, is we've only got one bit of information, which is this length here, 13. We don't know anything. We don't know another angle, and we don't know anything about the side. So we can't do anything with it. So what we need to somehow do is use this other bit of information to help us with this orange triangle. What we can do is I'll draw this in red. Oops. I'll draw this in red. So this red triangle here, we can find this length here. How can we do that? We can use Pythagoras. Okay, so if we use Pythagoras, if we've got any right angle triangle, let's call this side x. For any right angle triangle where we know 2 of the sides, we can find the 3rd side, as long as it is a right angle triangle. We know it's right angled because we've got this little sign here, which means it is right angled. So we can say x squared equals 3 squared plus 4 squared. So x squared equals 9 plus 16, which is 25. So x equals the square root of 25, which is 5. Okay, so we now know that this side here is 5. Now, if you were doing this question, you should put this down because this will give you method marks. So whenever you've got a question like this, you should always do what you can because you never know, you might get some method marks. This would be worth 1 or 2 marks. Right, now we can look at this orange triangle here. And now we've got what we need. We've got 2 sides. We've got 2 sides and we're trying to find an angle. So now that's the big question of what do we use? Well, if we remember so ka toa, which you've almost certainly seen before. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent. So we've got, if we look at the side, let's label them in black here, then this is my angle. So relative to my angle, this longest side, which is the one opposite the right angle, is always going to be my hypotenuse. This side here that's opposite the angle is the opposite, and this side here that touches the angle or adjacent to the angle but not the hypotenuse is the adjacent. So what have we got? We've got the adjacent and the hypotenuse, so we want to use this one here. So we're going to say that the cosine of the angle is going to be the adjacent, which is 5, over the hypotenuse, which is 13. So theta is going to be, we put in our calculator, cos to the minus 1 of 5 over 13. And if you do that, you will get 67.3801 and so on, which we'll call roughly 67.4 degrees. Okay, so that's the first one. Second one. So with this one, we've got to solve this quadratic equation. Why do we call it a quadratic? Because it's got this x squared term in it. We've got an x squared term, an x, and a constant term. So in order to solve a quadratic, we first of all need to factorize the quadratic. And how do we factorize it? We look for all the numbers that multiply, all the pairs of numbers that multiply together to make negative 21 and add together to make negative 4. So to get these modelled up, they multiply together to make this number, and they add together to make the coefficient of x, the number before x. So the best way of doing it, I find, is to write down all of the possible pairs that multiply to make 21. So the first one would be 1 and 21. You're always going to have that as a possibility. 2 doesn't go. 3 times 7 is 21. 4 doesn't go. 5 doesn't go. 6 doesn't go. And then we're back to 7. So these are my only options. They've got to multiply together to make negative 21. So one must be positive, one must be negative. And they're adding together to make negative 4. So obviously it's going to be these. Negative 4. So it's going to be minus 7 plus 3. So it's going to be x plus 3 times x minus 7. Okay, so I factorized this to get this. Now, why have I factorized it? I factorized it because if this times this is 0, then either this is going to equal 0 or this is going to equal 0. So if this equals 0, then x plus 3 equals 0. So x equals minus 3. Or this is 0. So x minus 7 equals 0. So x equals 7. Because anything times 0 is 0. So if this times this is 0, then either this must be 0 or this must be 0. So x is minus 3 or x is 7, and that is my answer. So x equals minus 3 or x equals 7. That's that one done. Okay, so this third question here has one of the main gotchas that people always get wrong in GCSE maths, y squared. So what did you put for that? Y squared, let's put the answers over here. So y is negative 2. So what's negative 2 squared? Did you put negative 4? If you did, you got it wrong. It's negative 2 squared. When we square something, we multiply that number by itself. So it's minus 2 squared, which is minus 2 or negative 2 times negative 2. And a minus times a minus is a plus. You should know that. So minus 2 times minus 2 is going to be 4. Okay, plus 4. If you put negative 4, you would get no marks at all. You'd be 8 away from the actual answer, which is 4. So very important you get the sign right. Number 2. Another sign problem here. So we've got 3x minus 5y. So 3x, when the numbers are next to each other, 3 times, that means 3 times x. So 3 times 3, which is 9. So it's going to be 9 minus 5 times y, 5 times negative 2. So it's going to be minus 10, negative 10. 9 minus negative 10. Now, if you're taking away a negative number, that is the same as adding the number. So it's going to equal 19. 9 plus 10, which is 19. All right. Again, if you put minus 1, you wouldn't get the mark. You might, depending on the question, get a mark if you show this negative 10. So when you have this type of question, substitutions they're called, when you have a substitution type question, you should always show you're working to try and get a mark. All right, so the actual answer should be 19. If you take away a negative number, it is the same as adding. So number 3, let's have a look at this one. So, whoops, hang on, should be that. That's what it was in the actual question. So z squared minus 2y squared is going to give me this, the square root of z squared, or z squared is going to be 25. 5 times 5, which is 25, minus 2y all squared. So if you remember your BIDMAS or BODMAS, then 2y is going to be negative 4. So it's going to be minus 4 squared. All right, 25 minus negative 4 squared. So that is going to give me the square root of 25 minus 4 squared is going to be minus 4 times minus 4, just like we had here, which is going to be plus 16. So it's minus 16, which is going to give me the square root of 9, which is 3. Okay, so my answer is going to be 3. Okay, right, next one, number 4. Find x. Let's look at this in a couple of ways we can do this. People always get confused with these questions because there are two different things we look at when we look at polygons. One is the total interior angles and the other is the exterior angle. So possibly the easier way of doing this, I think, is to draw an extension line here. And then we can look at two angles. I'll do them in different colors. Let's call this one, we'll call this one y, and we'll call this one here z. Okay, so y is the exterior angle. Remember, the exterior angle of a polygon, if we extend one of the sides, that angle there, which is the same as this angle here, is the exterior angle. This angle here is what we call the interior angle. So if I find the exterior angle of this shape and I add it to the exterior angle of this shape, then I will have my x. So I can start off by saying that x is going to equal y plus z. All I need to do now is find what y and z are. So to find the exterior angle of a polygon, all we do is we divide 360 by the number of sides. Okay, we divide 360 by the number of sides. So we can say y equals 360 divided by the number of sides of this shape. It's a hexagon, so 6. So that is going to be 60 degrees. Okay, so y is 60 degrees. And z is going to equal, we've got 8 sides in this octagon, so it's going to be 360 divided by 8, which is 45. Oops, 45 degrees. So if we add these together, we get 105. So x plus y, bit of the colours. So sorry, y plus z equals my answer, which is 105. 105 degrees. Okay, 105 degrees. Now, there's another way we could do it. Let's keep that on there, and I'll do it on a completely different slide. So the other way we could do it is we could find the interior angles. So if we found this angle here, let's do it in the colours again. If we found this angle here, we could call y, and we found this angle here, which we could call z, then all three of these angles, we've got angles around a point, so all three of these would add up to 360. So we can say that x, black, so we can say that x equals 360 minus y minus z. All we've got to do now is find y and z. So in order to do that, we need to, if we want to find the interior angle, then we could just find the exterior angle. We could, if you remember the exterior angle here, that was the exterior angle. We could define this, take the exterior angle and subtract it from 180. That's one way of doing it. The other way of doing it is we can say, right, I've got a 6-sided shape. The total interior angle, so all of these, if I add all of these together, there is a formula to find out what they all add up together to make. And that formula is 180, sorry, it's the number of sides, so it's n minus 2 times 180. Okay, n minus 2 times 180. So in this case, we've got 6 angles, so it's going to be 4 times 180, which equals 720. So all of these added together make 720. Now, because this is a regular hexagon, then each angle is going to be exactly the same. So each interior angle is going to be 720 divided by 6. Okay, it's going to be 720 divided by 6, which is, let me try that right, 120. Okay, so 720 divided by 6 equals 120. So we know that this y is 120. Let's put it up here. And that makes sense because if you remember from the last question, the exterior angle we worked out was 60. Okay, so as long as you can do with the polygons, you can do both of these things, you can find the interior and the exterior angles, then you are good to go. So that's going to be 120. So let's write it in here now, 120. And to find z, we're going to say this time we've got 8 sides. So 8 minus 2 is 6. So it's going to be 6 times 180, which is 1080. And then 1080, whoops, 1080 divided by 8 is going to be 135. Okay, so this is 135. So to find my angle x now, I can say x equals 360 minus 120 minus 135, which is going to be the same as before, 105. Okay, so I've shown you, but this way I think is much easier. I've shown you this way as well, because if you can understand that in fact we're doing exactly the same thing, we're going to get exactly the same answer, we're doing it 2 different ways. So on the one hand, we're straight away finding the exterior angles. On the other, we're looking at the interior angle based on the total interior angles. Right, final question. So this is another thing where people often forget what to do. All right. First of all, what does this minus mean? What the minus means is you take the reciprocal of the number. Now the reciprocal of the number, if it was, let's just imagine it was 4 squared, like that. Well, that should be easy enough. That's just going to be 16. 4 to the minus 2 is the same as the reciprocal of 4 squared. So the reciprocal of 4 is 1 over 4. So it's 1 over 4 squared. So it's going to equal 1 over 16. A quarter times a quarter is a 16th. All right, I'll give you a couple more at the end after this question. That's 1. 2, again, this is something that you must remember because it often comes up. Anything to the power of 0, anything to the power of 0. So 4 to the power of 0, x to the power of 0, a million to the power of 0, whatever it is, anything to the power of 0 equals 1. Okay, it always is. So anything to the power of 0 is 1. You need to remember that. Now, these are the 2 hardest questions. All right, so if you got these wrong, don't worry. But let's see if we can unpick them. When we've got what we call a fractional index like this, let's start with a slightly easier one. Let's say we had 4 to the power of 1 over 2. What does that fraction there mean? 4 to the power of a half. 4 to the power of a half means that we take the second root, or more commonly known as the square root of 4. So it's going to be the square root of 4, which is 2. If we had, let's say, for example, 8 to the power of 1/3, then we'll be looking for the cube root of 8. Cube root of 8, which also happens to be 2. In this case, we've got 4 to the power of 3 over 2, which means, so for part 3, we're going to find the square root of 4, that's the 2 at the bottom, and then we're going to cube it. So we could write it like this: 4 to the power of 3 over 2 is the same as the square root of 4 cubed, like that. So the square root of 4 is 2, so 2 cubed is 8. Okay, obviously if you put it in your calculator, it's very easy, but you've got to be able to do these for the non-calculator type questions. So it's going to be 4 to the power of 3 over 2 is 4 to the power of a half. That's the other way you could think of it, is it's the same as 4 to the power of a half cubed. Because remember, when you've got an index on the outside, then you multiply. So that would be the same as 4 to the 3 over 2. Right. Part 4. Now this one, by far the hardest. Okay, this is about the hardest type of index question you're ever going to get. You've got a mixed number and a negative fraction. So let's have a look at that, see if we can't unpick it. First thing we need to do is convert this into an improper fraction. So 2 1/4 is going to become 9 over 4. So 9 over 4 to the power of minus 3 over 2. Now we've got this minus, so we're going to take the reciprocal. When we take the reciprocal of a fraction, we just flip it. So that's going to give me 4 over 9 to the power of 3 over 2. So now we've got exactly the same as we had before, 3 over 2, so we're going to find the square root of 4 over 9 and then cube it. So it's going to be the square root of 4 over 9 cubed. The square root of 4 is 2, the square root of 9 is 3, so it's going to be 2 over 3 cubed, which is going to give me 2 cubed is 8, and 3 cubed is 27. All right, so if you got these last two right, you're doing very well. If you got all of these right, you're doing exceptionally well. If you got the first two right, that's good. Hope you understood these, and we will have more in future videos. So that is it. Thank you very much.